Okay, this here is going to be an example of a level 1 problem for finding the maxima and minima. So as you learn, the first step is going to be to find the derivative of the function first off, and that's going to come out to 6x squared. And then you're going to find which numbers plug into this function that's going to make this equal to 0, because your second step is setting the derivative equal to 0. So what you're going to get here is, if you plug in 0 into the function, it's going to be 6, 0 squared, and that's going to be 0. So x is going to be the number that we're going to use because that's the point of inflection. And we're going to plug this into the graph, or this bar graph, and you're going to choose a number smaller than 0 and bigger than 0. So for example, I'll choose -3 and +3. So basically, we're going to plug this number into the derivative first. So 6 to -3 squared is going to come out to 54, which is a positive number. And then we're going to plug in 3, which is going to give us 6, 3 to the power of 2, and that's going to be positive 54. So that's going to give us another positive number. So what we learned here is the graph is going to be going up and then up again. So 0 is going to be this on a graph would most likely look something like this and this. So 6x squared is going to be, 0 is going to be our relative minima. Okay, so this function is a little more difficult. It's going to be a level 2 problem. The first thing you do is going to find the derivative of this function. So that's going to be, you're going to have to use a chain rule on this one. So it's going to be 3x squared minus 1. And then you take the derivative of the inside of the function, and that's just going to be 2x. And to simplify this even farther, to make it easier, it's going to be 6x x squared minus 1. So basically from this, we're going to have to find our critical numbers, and we're going to treat these two things separately. So 6x, set that equal to 0, x is going to equal 0. That's one of your critical numbers. This function right here, you're not going to be able to solve straight from here. You're going to have to do this other method, and it's going to be x plus 1, x minus 1, which basically equals the same thing as this, but in a more broken down version. So from this, you're going to find out that your other two critical numbers are x equal -1 and x equals +1. So these are going to be your critical numbers. Okay, so once you're up to this point, we're basically at the point where we have to plug in the numbers at the intervals. So the critical numbers here are -1, 0, and 1. So the intervals that we're going to have to find, there are 4 intervals, which are going to be -∞ to -1. I'm just going to leave a little mark here. -1 to 0, 0 to 1, and 1 to infinity. And basically to find these numbers, you're going to have to plug in these intervals, basically, where these numbers are going to be, into your derivative. So essentially, if you look at this here, basically anything you plug into here, oh, sorry, I made a mistake. This is supposed to be squared. So anything you plug into there is going to be a positive number, and it's not going to be 0 because we're not plugging in -1, 0, and 1 because those are critical points. So anything we plug in here is going to be positive, so we can just leave this out. What we do need to focus on is this 6x. So this part becomes very simple. Basically, anything you plug into greater than 1 into 6 is going to be positive. Anything you plug in to 6x that's greater than 0 again is going to be positive. And then negative, it's going to be negative. Anything lower than -1 is going to be, again, negative. So this is what our graph's going to essentially look like. It's going to be going down and then up again. So this is what it would look like. And then 0 is going to be the point of inflection again. So it's going to go down, 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 and then up. So all the way from -50 to 0 is going down. And then from 0 to positive 50, it's going to be going up again. So what this means is that x equals 0 is going to be our local minimum. And that'll be all.